This is a picture of Triton, one of Neptune's moons. It was taken by a spacecraft nearly 30 years ago and is part of a limited batch of photos we have of this icy world. Scientists think this moon might have an underground ocean that could be hospitable for life, among other intriguing science questions. So they want to go back for a closer look. But there's a race against time and orbital mechanics. They want to launch soon so they can take advantage of a gravity slingshot from Jupiter.
Triton is a very large moon. It's the 7th largest moon in the solar system. Triton itself is larger than every other smaller moon combined.
But it is a captured world around Neptune. Something happened, we don't necessarily know what, that caused it to be captured into orbit around Neptune. When we first encountered Triton, when Voyager 2 passed by in 1989, we saw a world that was very unlike what we expected. We saw one of the youngest surfaces in the solar system.
We think it's maybe 50 million years, but perhaps as young as 10 million years. And so that might sound a lot to us as mere humans who are here for a blink of an eye. But in geological terms, it was essentially born yesterday.
We date the ages of surfaces in the solar system based on the number of craters they've experienced. And there were almost no craters on the surface of Triton. So that was the first clue, something weird is going on. The second clue was when we started looking even closer at the surface. We realized there were all these weird and wonderful features that we could interpret as being the result of movement of materials through an ice shell. And that was particularly exciting because that suggests there's an energy source, and an ocean provides a really nice energy source.
We also found that Triton had plumes of active material firing off from the surface in some way. So these dark columns going up to about 8 kilometers above the surface.
I've been captivated by these plumes ever since I saw them first in the Guardian newspaper in 1989. They were the first time we ever saw plumes erupting from an icy world.
Galactic plumes could be evidence of a subsurface ocean, which might support alien life. We see them on other distant moons too, like Enceladus.
There's been a lot more interest in some of these icy bodies, I think. They're very unusual and alien-looking, bizarre landscapes, but they're also now possibly places where life might have evolved or might evolve in the future.
And all of these intriguing hints are what make Triton a prime target for a new flyby mission.
So Trident is a mission concept that we are proposing to NASA in the next Discovery round. So we want to launch in October of 2025, and we would arrive at Triton in 2038. One of the kind of ingenious things about this is that 30 years after Voyager, our technology has come on so far that we can do nearly global mapping of the surface just from a flyby. So we're also flying much lower. Voyager flew by at about 40,000 kilometers. We are flying by at about 300 kilometers, so we're going very close to the surface. There are a lot of cases where you can do a huge amount of really fundamentally important science just from a flyby. The New Horizons spacecraft flew by Pluto a few years ago and showed what an incredible world Pluto is. I myself worked on the Messenger mission where we answered a lot of the science goals just from one flyby, if you carry the right tools and you plan everything correctly.
Trident is carrying a fairly complex suite of instruments. The first one is a combined narrow-angle camera and infrared spectrometer. The next one is a magnetometer, and that has one real purpose, which is to look for the magnetic signature of an ocean as we fly past Triton. Then we have a plasma spectrometer. This is an instrument that samples particles along the trajectory of the spacecraft. Then we're carrying a wide-angle camera. This is specifically intended to image the Neptune-facing hemisphere of Triton during the eclipse. Finally, we're using radio science. So that will give us a lot of understanding about the atmosphere, and it will also help us detect more or less where the bottom of the water layer is.
But to get to Triton under the Discovery budget, they'll want to hitch a ride on a smaller rocket and use radioisotope thermoelectric generators as a power source. They want to launch soon so they can take advantage of a uniquely suited flight path.
In terms of propulsion, our trick is that we're using what they call a ballistic trajectory. Trident is being thrown into space. It's going to do a few flybys of Venus and Earth, then it's going to shoot out to Jupiter and then get what they call a gravity assist, where Jupiter will both deflect the trajectory and accelerate it straight at Neptune. This is one of those wonderful examples of a very pure application of physics. We should be able to hit exactly the right point relative to Triton within 20 kilometers. We're at JPL. This is what we do. We do these crazy missions to far out places, and we bullseye our target decades out in the extremes.
We just a couple of hours ago submitted what's called a notice of intent to NASA that says we are going to deliver to you in a few weeks a proposal to go and explore Triton. So at this point we're very close to the end of getting the proposal ready. We're not getting a lot of sleep. It's a very exciting and exhausting but overall exhilarating time to be doing this kind of work. One thing about this mission is that it is unusually long. You know, if you're going to the moon, it's 3 days away. If you're going to Mars, you can get there in 9 months. It takes us 13 years to get to Triton.
It's very, very rewarding. And it's worth putting in all the extra time and sweat. You don't just want to look at the familiar. You learn a lot more about studying the unfamiliar, the things at the extremes.
Seeing the surface of a planet for the first time is, it's hard to describe what that feels like. It's almost spiritual. You're seeing something sometimes that no one else has ever seen. Or certainly no one other than the people in the room, you know, that you're all standing around a screen, usually going crazy. It's a pretty incredible moment, and they don't happen very often in a career, but when they happen, they're pretty magical. It's worth the wait.
For more science documentaries, check out this one right here. Don't forget to subscribe and keep coming back to Seeker for more videos.